Another example of a calculus question, we're looking at exercise 4I from the book 1E. So we're just asked to find the first derivative, dy dx, and we're given that y equals quantity 1 minus root x over x cubed. First glance, I can see that there's both a quotient, because I have an x in the numerator and the denominator, but then that entire quotient is to the power of 3. So starting with the most basic thing, I can see that it is a composite function. Here I have my inside, here I have my inside, and here is my outside. You could use some sort of expansion to get this to the third power. That seems pretty tricky. I'd rather just go more straightforward. So I know when I try to take the derivative of that inside function, I will encounter the quotient rule. But I'll get started first. Clearly, this is starting out with a chain rule, so I identify my inside function as 1 minus root x over x, and my outside function is y equals u cubed. I need to take the derivative of each of these. I'm going to slide this way down here because I know to take the derivative for u, I'm going to need a lot of space. So I want to take the derivative of this u function here, but it itself requires another rule. I can see that there's a numerator and a denominator. So let's go ahead and call this a numerator. I can't call it u. I mean, I guess I could, but I've already used u, so I'm going to use w. So I have w equals 1 minus root x. May as well already write that as x to the power 1/2. And then I have my denominator here. I can still call it v. I haven't used v yet, so v equals x. For the quotient rule, I need to take the derivative of each. I realize I'm mixing notations here, but the only time when we're changing the variable that we're taking the derivative with respect to is the chain rule. So the only time I will insist on using the Leibniz notation is with the chain rule. So here I take the derivative with respect to x. It's going to be negative 1/2 x to the power negative 1/2, and v is going to have v prime is going to be 1. So putting this together, du dx, it's the derivative of u with respect to x, is going to be w prime v, so negative 1/2 x to the negative 1/2 times x, minus v prime w, so 1 times 1 minus x to the 1/2. Be very careful about that bracket. This negative applies to everything inside that bracket, so make sure you don't forget that. All over v squared, so that's x squared. And let's go ahead and simplify this. Exponents rules. X to the negative 1/2 times x, so like this is to the power of 1. I'll add them together. Negative 1/2 plus 1 is positive 1/2. This is going to be negative 1/2 x to the 1/2 minus 1 plus x to the 1/2, expanding that bracket. Okay, I have like terms. I have an x to the 1/2 like twice in the numerator, so I can combine those. Negative 1/2 x to the power 1/2 plus 1 x, again, like negative 1/2 plus 1. I'm looking just at the coefficients is 1/2, so I have 1/2 x 1/2 minus 1 over x squared. There's a lot of 1/2s out loud. I can't move that 2 into the denominator of the overall fraction without first dealing with the fact that there's this minus 1. So for the moment, I'm just going to leave it like that. And now, getting back to the chain rule, I realized I had to scroll and now we can't even see things. Over here, I need to take dy du. So that'll be 3u squared. But I'd really like to see this in terms of x. So I'll write 3 and rewrite this as 1 minus root x over x, and that is now to the power of 2. I'm only being silent. I'm trying to think about what's the best way to combine these. It's just going to be a lot of algebra no matter what we do. So let's go ahead and throw it back together. So the chain rule says that dy dx is dy du. So that's this 3 times 1 minus root x over x squared times du dx, which is 1/2 root x minus 1 all over x squared. Okay. Multiplying these, I think it's actually going to multiply pretty nicely. So I have a 3 in the numerator I have an x cubed in the denominator. There's this, oh, not cubed, because this is squared. So there's this one that becomes squared with this other one. So I now have x to the power fourth. And in the numerator, I now have 1 minus root x squared times, I'm going to put this in brackets so I don't accidentally forget that the negative 1 is multiplied by everything, 1/2 root x minus 1. Whether you are motivated to expand this numerator or not really depends on what the question asks. I'm not super motivated to do it right now in this moment. It would probably simplify kind of nicely. We have roots and squares, but unless they specifically say I have to, I'm going to leave it like this.